Hi everyone! Finally, I've reached the part where I configure my home server for gaming. In this video, I will show how I set up Unraid for gaming, run games in console mode on a TV and on my ultrawide monitor through a laptop. And of course, we will see what kind of FPS this server can actually deliver. I see two main gaming scenarios for myself. First, gaming in the living room on the TV. The server is installed inside my TV cabinet, so I can connect the 4K TV directly via HDMI to the GPU, grab a controller and play like a console. This is the simplest scenario because there is no streaming involved, everything runs locally. The second scenario is gaming at my desk, using keyboard and mouse on an ultra-wide monitor. My desk is in another room, so running an HDMI cable is not realistic. That means this setup relies on gaming streaming over the local network. As a reminder, the CPU in this server is a 6-core AMD Ryzen 5 Pro 4650J. It's not really designed as a gaming CPU, so in this video I will test whether it makes sense for a universal home server or if something else would be a better choice. First, we need to enter BIOS and enable several virtualization features. Now we enable SVM mode. This turns on CPU virtualization support, which allows us to run virtual machines. Next, enable I/O MMU. This allows hardware devices like GPU to be passed directly into the virtual machine. Then enable above 4G decoding. This is required for modern GPUs and proper PCIe resource allocation. And finally, set Unraid to use the integrated GPU as a primary display, so the dedicated GPU stays free for pass-through. Save settings and reboot. Before configuring the VM, we need to pass through the GPU and the SSD directly. Go to Tools, System Devices. Here we will find the SSD, but notice that the checkbox cannot be enabled. That's because Unraid has already attached a driver to this disk, so we cannot pass it directly to a virtual machine yet. Now go to Settings, VM Manager, and change PCIe SCS Override. Both. Allow unsafe interrupts. Yes. Apply changes and reboot. This step splits PCIe devices properly, so they can be assigned individually. After reboot, go back to Tools, System Device, select GPU, GPU audio device, and SSD. Click Bind selected to VirtIO and reboot again. Now you should see a green indicator next to the GPU and SSD. To avoid shattering performance in virtual machines, we need to isolate CPU cores for Unraid. Let's go to Settings, CPU pinning, select cores that will not be available to Unraid. In my case, I leave cores 0, 1 and their hyper-threaded pairs 6 and 7 for Unraid itself. Apply changes and reboot. Now it's time to create the virtual machine. I'm using Windows 11 downloaded from the official Microsoft website. Let's create new VM. Give it a name, assign CPU cores, excluding the installation ones, allocate 16 GB of RAM, machine type Q35 latest version, select Windows 11 ISO, primary with disk location none, because we will install directly onto the pass-through SSD. Graphics. Leave virtual GPU enabled initially so we can access VNC during setup. Then add NVIDIA as a secondary GPU and select GPU audio device. Network model, we need VirtIO net. Under other PCI devices, select the SSD. Click Create. Open VNC, press any key and start normal Windows installation. Once Windows loads, first install VirtIO drivers from the mounted image. Then install NVIDIA GPU drivers. Next, configure RDP so we can disable the virtual GPU later. Shut down VM. Edit VM settings. Remove virtual GPU. Leave only the physical NVIDIA GPU. Add controller path-through for gamepad. After installing games, I started performance testing directly on the TV. All tests were done in 4K. Dirt Rally was labeled only on ultra-low settings to keep a stable 60 FPS. Medium settings dropped to around 40 FPS, which felt a bit choppy for racing. The CPU was working harder than the GPU, so 4 cores just aren't enough for this game. Fallout 4 showed the same story. It ran around 50 to 60 FPS on ultra-low settings. Playable, but there were occasional stutters. GTA 5 was more demanding. The open world really stressed the CPU and changing graphics settings didn't help much. On normal settings, FPS was between 40 and 60, while on ultra settings it stays around 40 with some stutter. The GPU still had headroom, but the CPU was the bottleneck. Rocket League ran perfectly with a stable 60 FPS on medium settings. Now let's configure second scenario. Playing on a laptop over LAN. Running HDMI cable isn't an option, so we need game streaming. Two main approaches exist: Steam Remote Play, third-party solution like Moonlight plus Sunshine. Based on Reddit feedback, Moonlight provides better performance, so I choose that route. Instead of Sunshine, I'm using Apollo, a fork with additional features. Apollo can automatically create a virtual display matching the client resolution and refresh rate, which makes streaming much more flexible. Now I will show you how I set up Apollo for game streaming step by step. First, we install Apollo on the Windows virtual machine. After that, we enable headless mode, so the system always creates a virtual display. This is important because we want streaming to work even without a physical monitor connected. Next, we need to find the IP address of the VM. You can check it directly inside Windows Network settings. Now we move to the client device. I'm installing the Moonlight client on my laptop. Once it's installed, we add the server manually by entering the VM's IP address. After that, we confirm the pairing through the Apollo web interface. Here I assign permission to client, so it can connect and start streaming. Now we adjust a few settings. I set the resolution to ultrawide and choose a bitrate of around 40 megabit per second for good image quality. Then we connect using the virtual display option and finally launch the games. Performance was very similar to playing directly on the TV, so streaming over the local network didn't really change the results. In GTA 5, FPS was around between 40 and 60 depending on the location and how heavy the sign was. Fallout 4 ran around 45 FPS on low settings. Playable, but you can feel that the CPU is the main limitation. Rocket League performed very well, with a stable 60 FPS even on ultra settings. Dirt Rally was also stable at 60 FPS on ultra low settings, so overall it felt smooth and comfortable to play. Let's talk about the power consumption. When the system is idle and no one is connected, the GPU drops into a low power state and consumes around 15 watts. With the virtual machine running, but the system otherwise idle, total power usage sits at around 46 watts, which is actually quite reasonable for a server like this. During gaming, power consumption naturally increased depending on the load. And in my tests, the system peaked at around 150 watts. That gives a good idea of the real-world operating range. Relatively efficient in idle, but still capable of delivering enough performance when needed. So after all the testing, what's the real takeaway? GPU Passthrough works great, Unraid handles gaming VM surprisingly well, and the overall experience feels much more closer to bare metal than many people expect. But at the same time, the build clearly shows where the limits are. The bottleneck here isn't the GPU, It's the CPU. In modern games, especially open world titles, the processor simply runs out of headroom, and that directly affects frame consistency and overall smoothness. That doesn't mean the concept doesn't work, quite the opposite. What really shows is how important CPU choice is when building a universal home server that also doubles as a gaming machine. Even a small upgrade to something like Ryzen 7 Pro 4750J or any higher core count CPU would likely change the experience significantly. And honestly, even though the results weren't perfect, I still wanted to share the process, because setting up GPU Passthrough in Unraid turned out to be much more accessible than it might seem. And with the right hardware, this can become an incredibly powerful all-in-one system. So this isn't the end of experiment, it's just the beginning. Thanks for watching, and I will see you in the next video.